Walk along the shoreline of Southern California's Salton Sea, and the first thing you'll notice is the smell of hydrogen sulfide, a heavy scent of rotten eggs. Look down, and you'll realize the crunching beneath your feet is a thick layer of sun-bleached fish skeletons. As this landlocked lake evaporates, it exposes miles of dry lakebed packed with agricultural runoff. The wind kicks that toxic dust into the air, spreading particles of arsenic and pesticides into nearby communities. Today, nearly 1 in 5 children in the surrounding Imperial Valley has asthma. By every visible measure, this place is an ecological liability. Yet, 3 different companies are currently racing to set up operations right on these toxic shores, because this shrinking disaster zone has recently been identified as one of the most valuable plots of land in America. The value isn't on the surface. While the lakebed above is an economic dead zone, the subterranean layers below hold a lithium reserve worth an estimated $500 billion. This diagram illustrates what's happening 10,000 feet underground. The Salton Sea sits directly on top of the Salton Trough, a rift zone where the Earth's crust is pulling apart. Deep magma pushes heat upward, creating a subterranean aquifer filled with liquid that reaches up to 600 degrees Fahrenheit. That boiling liquid is packed with lithium. Over the next decade, the U.S. requires a massive supply of this metal to build electric vehicle batteries and power grids for AI data centers. Right now, China produces roughly 80% of the world's lithium-ion batteries. A Department of Energy study suggests this single underground deposit contains enough lithium to build 375 million electric vehicle batteries. The United States essentially has a strategic reserve trapped beneath a fragile environmental disaster zone. Extracting it using traditional open-pit mining would likely cause further ecological damage, creating a conflict between local health and national industry. Energy companies have already established an industrial footprint here. Looking at this facility right on the shoreline, you can see the infrastructure is already in place. Since the early 1980s, these plants have been tapping into the region's heat to generate geothermal electricity. For decades, their process involved pumping the boiling, mineral-rich brine to the surface to create steam for power generation. At the time, the leftover mineral sludge was viewed as a destructive, disposable byproduct that corroded pipes and equipment. Because the geothermal industry already hauls 121 million metric tons of this brine to the surface every year, the heavy lifting of the mining process is essentially a byproduct of electricity production. The challenge is capturing the lithium before the brine is sent back underground. Direct lithium extraction is a closed-loop cycle. Underground brine rushes up a pipe, spinning a turbine to generate clean electricity. Cooled brine then flows through a chemical resin, pulling lithium out. Finally, the remaining brine is injected back underground, extracting the resource in hours. There's a reason this hasn't been scaled up yet. The extreme heat and pressure that make the brine so mineral-rich also make it chemically destructive. As the fluid moves through the system, it deposits silica, a hard mineral that quickly clogs filtration equipment. To manage this, engineers must build these plants using expensive materials like solid titanium and high-nickel alloys. In a standard geothermal plant, pipes might last 10 years. Here, they can be eaten alive in just 18 months. Solving this metallurgical bottleneck is the primary hurdle for establishing a large-scale domestic lithium supply at the Salton Sea. Companies aim to have these commercial-scale extraction plants fully operational by 2027. If they can solve the corrosion issues, the timeline for production is relatively short. Unlike open-pit mining, which requires clearing miles of land, this technology operates within the footprint of an existing power plant, significantly reducing the impact on the local environment. As seen on this assembly line, a domestic supply chain for these materials directly impacts American manufacturing. A functional Salton Sea operation becomes a dual-engine asset. It provides carbon-free electricity while securing the lithium needed for the next generation of transportation. The economic shift could change the outlook for the communities surrounding the lake, which currently face high unemployment and the ongoing public health risks of toxic air. Tax revenue from a multi-billion-dollar lithium industry would provide a consistent source of funding to mitigate the toxic dust and begin restoring the shoreline. It creates a scenario where the industrialization of the deep earth provides the financial resources necessary to repair the damaged ecosystem on the surface.